The field is now directed outwards there and inwards there.
Glatzmeyer's model shows that the magnetic poles swap places spontaneously due to complex processes within the core.
We're very used to the idea that a compass points somewhere near the North Pole, and hence we can use it for navigation. But there were periods in the past when the compass would have pointed in exactly the opposite direction.
Glatzmeyer's research also suggests that there's a decline in the magnetic field strength before and after these reversals. Does this explain why the magnetic field is currently weakest beneath the South Atlantic? Are the magnetic poles about to reverse?
We've never witnessed a reversal, so we don't really know what it would look like. But we could guess. And it would almost surely take the bubble of the magnetosphere and contract it inward, closer to the surface of the Earth.
If this is the start of a magnetic field reversal, our planet will face increasing exposure to cosmic radiation for thousands of years to come. But so far, the random reversal of the Earth's magnetic field has only been seen inside a computer. For concrete evidence, scientists turn their attention to the volcanic islands of Hawaii. Locked inside this ancient lava is a pristine record of Earth's magnetic field stretching back millions of years. Professor Emilio Herrero Bevera is searching for clues to Earth's magnetic past.
One of the reasons why we're coming here is because we're looking at lava flows that are relatively thin. You can see the boundary of this lava flow, and this is the other boundary. From here you see another one, and another one, and another one. All these fantastic sequence of lava flows, we're talking about 300 flows, 400 flows.
Molten lava from these island volcanoes accumulates over millions of years. When the lava flows hit the seawater, they cool rapidly, creating snapshots of Earth's magnetic field strength. By analyzing different samples of lava, Herrero Bevera has built up a picture of how the field has changed since long before humans were around.
They are actually the recorders of the Earth's magnetic field in hundreds of years, thousands of years, and this is what we need actually to know something about the Earth's magnetic field.
Lower layers of rock take Herrero Bevera progressively further back in time. To unlock the information, he takes a sample of the ancient lava. As well as showing how the field strength has changed, the sample will also reveal another vital piece of information. He carefully notes the sample's exact location.
And we're going to measure the magnetization of the sample we collected in the field.
Back at the lab, he analyzes it using a magnetometer. Like pottery, lava contains magnetite. When it cools, particles of magnetite line up with the Earth's magnetic field like tiny compass needles, recording both its strength and its direction. In this sample, the magnetite aligns with today's magnetic north.
This sample was in place in the past 700,000 years when the field was actually characterized by a normal polarity.
But in older samples, they discover something incredible. The magnetic particles point south rather than north. They date back to a time when the magnetic field polarity was the opposite of today's.
There was a reversal actually recorded by these lava flows. I will be actually able to see a sequence of points that are actually defining the behavior or the evolution of the magnetic field from one polarity to the other polarity.
By analyzing thousands of lava samples, Geophysicists discover that the Earth's magnetic field has reversed over 18,000 times in the last 20 million years. On either side of these reversals is a long period of dramatically reduced field strength.
During this process of reversal, the magnetic field drops very significantly in intensity. And this happened many, many, many times throughout Earth's history. You know, the Earth is 4.5 billion years old, and I'm saying it happens every few 100,000 years or so.
Years of research reveal that the last reversal occurred 780,000 years ago.
It's easy to understand why there's such an interest in the possibility of a magnetic reversal. The last magnetic reversal occurred more than 750,000 years ago. And so, in a real sense, we're overdue for another. And so the question is not if another reversal will occur, but when.
Many scientists now believe that the South Atlantic anomaly is the start of a global magnetic field reversal. The decay of our magnetic field will accelerate, with serious consequences for life.
The kind of radiation we're talking about is known to damage DNA and RNA and cell structure, and it is a serious cause of cancer incidence.
On Earth, magnetic field reversals are comparatively rare and erratic, but on our nearest star, they occur far more frequently.
Every 11 years, the direction of the sun's magnetic field flips. So the sun's magnetic field oscillates regularly, whereas the Earth has these long periods where the geomagnetic field's direction remains more or less constant, and then it flips suddenly.
Although the sun's magnetic field isn't generated in exactly the same way as the Earth's, scientists still observe it closely.
So you get these very different dynamos operating under the same laws of physics, under little different environments. So by studying both of them and comparing them, we learn more about both possibilities.
During its magnetic cycle, the sun undergoes periodic changes in activity. Every 11 years, it enters solar maximum.
This 11-year cycle of solar activity has peaks where there's lots of solar storms, and right now where the sun's taking a little nappy. But in about 4 years, we're headed back for solar max. Big storms, big disruptions.
In 2012, the sun's activity will peak. For 3 years, the build-up of magnetic energy will generate dark sunspots, an increase in solar flares, and hurricane-force solar winds.
Almost every solar max, there are satellites that are killed. The last solar max destabilized the North American power grid and caused massive blackouts during one of the storms. And these are not small storms and inconsequential.
Earth's magnetic field continues to weaken. Soon, this intense solar bombardment could kill more than just power. The imminent field reversal will have a radical effect on human civilization. But it will also threaten the survival of a number of species. Dr. Richard Holland has discovered that as well as using sonar, bats use the Earth's magnetic field to navigate. Holland wants to know how their navigation will be affected by a reversal of polarity.
We catch bats here in this barn at the Princeton University Field Station, and we subject them to a manipulation of the Earth's magnetic field, or perhaps we disrupt the sensory cells that might be responsible for the detection of the Earth's magnetic field by bats.
Holland places individual bats inside this coil.
And zap the bat.
It delivers a very short, harmless magnetic pulse, which scrambles their internal compass.
And pow, there goes the pulse. So he's been magnetized. Hopefully that should have reversed the polarity of the magnetite in his sensory cells. So now we're going to get out there, release him, see where he goes. we drive them about 20 miles away to the north and release them, and we track them as they try to fly back home.
He's off, okay.
Holland wants to see how the magnetic pulse will affect their ability to navigate home. Bats normally fly back to the barn in around 60 minutes. But what happens to those whose senses have been manipulated?
No, that's it. He's gone. He's gone. He's gone, and he's headed north. So this guy, he's had his polarity reversed, his magnetic compass was screwed up, he's gone in the wrong direction. But eventually he'll correct and he'll get back to the home roost.
It takes the bat several hours to make it back. Holland believes that bats sense Earth's magnetic field lines. So when the magnetic field reverses, it's as if they're navigating with an upside-down map. Inevitably, they go the wrong way.
There's very clear behavioural evidence that animals use the magnetic field for a compass, certainly, and also possibly as a map.
But fluctuations in the magnetic polarity don't just affect bats. For decades, whale beachings mystified scientists. But in the 1980s, biologists noticed a correlation between the location of whale strandings and sudden magnetic anomalies on the sea floor. A weakening magnetic field could cause the leader of a whale pod to misread its internal GPS, leading others into dangerously shallow water.
There is the potential for this to affect animals' ability to locate their position using the magnetic field. The Earth's magnetic field is a mechanism of locating their position on the Earth has been vital for animals throughout the history of life on Earth, and so it's hard to imagine life without the magnetic field.
An absence of the magnetic poles could be disastrous for many species, including us. Earth's magnetic field has reversed thousands of times since its formation 4.5 billion years ago. And scientists now believe that the next reversal is imminent. The race is on to predict exactly when it will occur. In 2010, the European Space Agency will launch Swarm. Its mission is to generate accurate, up-to-the-minute maps of the Earth's magnetosphere and anticipate its future activity. Professor Nils Olsen of the Danish National Space Center is working on the mission.
The new and exciting idea behind Swarm is that we have 3 satellites. We have a higher satellite at an altitude of 530 kilometers, and we have a pair of satellites at an altitude of about 430 kilometers.
These identical satellites are equipped with new generation magnetometers. These will detect minute variations in field strength, as well as identifying any new areas where the poles are reversing.
I think it's amazing that we can take magnetic measurements by satellites flying at a few hundred kilometers and say something about the deep interior of the Earth, how the molten iron moves at a depth of about 3,000 kilometers. Isn't that amazing?
Scientists hope these satellites will help them predict when the magnetic poles are about to switch. They might even save lives.
I think that in the next decade or two, we could develop a science to forecast where the Earth's magnetic field is headed and use that then as a planning tool. Use that as a planning tool for people who fly satellites, as a planning tool for people who fly manned spaceflight, and develop the technologies necessary to deal with, let's say, an impending reversal.
As the reversal approaches, the decay of our magnetic field will continue, and cosmic radiation will get increasingly close to the Earth's surface.
Life on Earth, although it would be affected adversely in some ways by the drop in intensity of the Earth's field, it's figured out a way to live through these events.
So what should we do to ensure the survival of the human race?
There's very little we can do directly about the geodynamo. It's going to behave the way it wants. But now with satellites, we're able to look at it more